So, you want to learn how to code. Most people learn coding the wrong way and waste months binge watching tutorials instead of actually coding something themselves. Whether you're thinking about making this your career or you just want to build something cool on your own, in this video, I'm breaking down 6 effective steps to learn coding faster and start making cool stuff. Don't skip any of these steps because each one builds on the last. Step number 1, change your perspective. Coding can seem scary at first. All those lines of code, the technical terms, and this idea that you need to be some kind of genius to figure it out. This is not true. Before you write a single line of code, you need to shift how you think about programming. Most people approach coding like it's about memorizing syntax, thinking they need to learn every command and rule by heart, like studying vocabulary for a foreign language exam. That's the wrong approach. Coding is really about training your brain to think like a problem solver, not a memorizer. For example, if you want to display music on a website, the problem is, how do I show the song titles? Coding is just writing instructions so the computer can solve that problem for you. The real skill is thinking logically. Ask yourself, if I want this result, what steps do I need to follow? This shift in perspective is what will truly make you progress. When you start coding, it's important to immediately challenge yourself by solving problems, even if they're simple ones. At this stage, it's essential to learn how to break down a complex problem into smaller pieces. Verify that each step works correctly, and then translate those solutions into code using a programming language. Online, there are sites like Code Step by Step that offer exercises to help you improve your problem-solving skills. Step number 2, choose the language to learn. There are dozens of programming languages, and trying to learn a little bit of everything will drive you crazy. Instead, focus on one language, master it, and only then you can think about exploring others. Your first language choice should be guided by what you want to do. Each language has its own strengths and specific domains. C is a great companion if you want to develop operating systems. JavaScript, on the other hand, are excellent if you want to create interactive websites, while Java is better suited for those who want to develop Android apps. Anyways, I suggest starting with Python for a few key reasons. First, because it's flexible. You can use it for practically everything, from automating boring tasks to web development, from data analysis to artificial intelligence. It's easy to learn. Its syntax is clean and similar to everyday English, so you won't get lost in complicated rules, and you can really focus on fundamental concepts from day one. Finally, Python programmers are among the most in demand in the job market, with an average annual salary of $124,000. Which means that online, you'll find a huge support community, tons of guides and tutorials, and ready-made answers to the most common problems, which makes the entire learning journey much more effective. To learn Python, there are tons high-quality resources. YouTube is full of step-by-step video courses. Sites like WeSchools offer clear and concise lessons to quickly learn the basics, while platforms like Python Tutor let you visualize code execution, helping you understand exactly what's happening behind the scenes. Step number 3, study smart. Studying smart is essential for anyone who wants to learn new skills, especially in the world of programming. It's not just about spending hours in front of the screen, but organizing time and energy to maximize learning. Here are some strategies that help make studying more productive. Setting realistic goals. Instead of saying, I'll learn to code this month, set something specific and sustainable, like, I'll spend 1 hour a day on coding basics for the next 3 months. This way, you know exactly what you need to do every day. Create a ready work environment. When you start coding, the first fundamental step is to install the development environment directly on your computer. Having coding software installed offers many advantages compared to using online programs. If you want to use Python, you simply need to download and install it from the official website python.org, following the instructions for your operating system. With Python installed, it's helpful to also use a code editor or an integrated development environment like Visual Studio Code, which makes writing code more organized. Take breaks when you're stuck. When you get stuck on a problem, especially after hours of failed attempts, your mind tends to freeze. At that point, it's better to pause, change your environment, and come back to the problem with a fresh mind. Write comments in your code. Writing explanatory comments inside your code isn't just a good habit for yourself. It also helps you better understand each step when you return to review your work later. Step number 4. Use the Pareto principle. The Pareto principle states that 80% of the results come from 20% of the effort. In coding, by mastering the core 20% of a language's fundamental concepts, you'll be able to write about 80% of the code you'll produce in real-world situations. This means you don't need to master every single aspect of a language to be productive. Among these key concepts, there are 5 fundamentals you need to focus on. The first one are variables and data types. Think of variables as labeled boxes, where you store information in your program. Each box has a name and can hold different kinds of data. The 3 most important data types are strings, which are sequences of characters used to represent text, numbers, and booleans, which are a data type that can have only 2 possible values. Think of booleans like light switches. They can only be on or off. Next is control flow. This is how you tell your program to make decisions and repeat actions. The 2 main tools are if-else statements, which let your code make decisions. If the user is logged in, show their dashboard. Else, show the login page. It's like giving your program the ability to think and choose different paths. And loops, which allow you to automatically repeat a block of code multiple times without writing it 100 times. The main types of loops are the for loop, used when you know in advance how many times you need to repeat something, and the while loop, used when you don't know beforehand how many times to repeat, but you know when to stop. Functions. Functions are reusable blocks of code that perform specific tasks. Think of them like recipes. You write the instructions once, give them a name, and then you can use that recipe anytime you need it without rewriting everything. For example, if you need to calculate tax multiple times in your program, you create a calculate tax function, and whenever you need to calculate tax, you just call that function. Simple data structures. These are organized ways to store multiple pieces of information together, so you don't need hundreds of separate variables. The 3 you need to know first are array. Ordered lists where each item has a numbered position, like the test scores. Lists. Similar to arrays, but more flexible. Lists can hold mixed types, while arrays are better for math operations on same type data. And dictionaries. These are data structures that store information in key value pairs. Think of them like a real dictionary where you look up a word to find its definition. With dictionaries, instead of accessing data by position like lists, you access data using keys. Each key is unique and maps to exactly one value. And debugging skills. Debugging means finding and fixing errors in your code. It's not an exaggeration. You'll likely spend about 70% of your time debugging code instead of writing new code. According to statistics, developers on average create 70 bugs per 1,000 lines of code, and about 15 of those bugs make it all the way to the customers. So, the better you get at spotting and fixing bugs, the less time you'll waste being frustrated. On that note, I recommend following these steps to handle errors effectively. Step number 1, read the error message carefully. In most cases, the error message tells you what type of error it is and what went wrong. If you see this, it means you're mixing text and numbers without proper conversion. Like in this case, while you should write it like this. Step number 2, identify the cause of the bug. To get started, the simplest way to understand what caused the problem is to use print debugging, which involves placing strategic print statements in the code to see what happens step by step. However, if you're working on more complex code with many variables, it's better to use more professional tools like the debugger built into the IDE. By using breakpoints, you can stop the program's execution at a specific point and inspect exactly what's happening at that moment. Step number 3, correct the error. Once you've identified the problem, all that's left is to implement the fix, test the code, and make sure it works correctly. By mastering just these 5 concepts, you can solve about 80% of the programming problems you'll encounter. This doesn't mean you should neglect all the other concepts, but it's crucial to focus first on solid foundations that allow you to handle most common situations. As you progress, you can dive into more complex topics. Step number 5, put what you learn into practice. One of the most effective study methods in general is called learning by doing. In coding, this becomes even more critical. After you learn a new concept, don't just let it sit in your notes. Open your editor and actually use it right away. That's the fastest way to really get it. To build this habit, try to complete at least one project every few weeks, starting with simple ones and gradually increasing the difficulty. And if you ever run out of ideas, websites like GitHub have thousands of project ideas you can choose from that matches your current skill level. Step number 6, use AI. Artificial intelligence has made coding much more approachable, even if you've never programmed before, and it can significantly accelerate your learning process. But it should not completely replace your own thinking and coding. If you just copy and paste AI-generated code without comprehending it, you might never actually learn how to code. When you encounter a concept you don't understand, ask the AI to explain it as if you were a high school student with zero coding experience. When you're stuck on an error, you can't figure it out, paste your code and error message into the AI and ask it to explain what's wrong. Or ask the AI to create coding challenges at your level. For example, give me 5 beginner Python exercises about loops, then solve them yourself without AI help. The goal is to learn how to code yourself, and AI is just a tool to help you get there quickly. If you enjoyed this video, leave a like and let me know in the comments what topic you want me to cover next. Bye.